Welcome, future clinicians. Let's just jump right into today's explainer on the neurobiology of anxiety circuits. Today, we're going to examine 9 distinct anxiety disorders. And right off the bat, I need you to completely step away from the outdated, unhelpful idea that these conditions are somehow character flaws. Instead, we're going to look at them as predictable, highly observable neurobiological loops where the brain's ancient survival system has essentially gotten stuck in the on position. So here is our syllabus for today's clinical rounds. We'll start with the neuroanatomy of the hijacked brain. Next, generalized and panic states. Then, environmental and social triggers, followed by somatic and attachment loops. From there, we'll cover performance and obsessive circuits, and we'll wrap up with rewiring the plastic brain. All right, Section 1, Neuroanatomy of the Hijacked Brain, the Baseline Mechanisms. The foundational concept you absolutely must grasp here is that your patient's brain is essentially being hijacked. In every single type of anxiety we're going to cover today, the amygdala, our primal fear center, seizes total control. Meanwhile, the prefrontal cortex, which acts as the brain's rational braking system, is severely weakened. You add in a dysregulated HPA axis to that mix, and you've got a brain that's pumping out heavy stress hormones long after any real threat has actually passed. Think about the physical, structural consequences of that hijack. A healthy brain utilizes the HPA axis for exactly what it evolved for, which is short-term, immediate danger. But an anxious brain? It floods the body with this daily cortisol drip that's meant for running from a saber-toothed tiger, not for, say, checking your morning emails. Over time, this chronic exposure literally begins shrinking the hippocampus, which is responsible for memory, while simultaneously enlarging that fear center. The brain's physical architecture is actually changing before our eyes. Moving right along to Section 2, Generalized and Panic States, the constant versus the sudden. For your diagnostic baselines, the neuroimaging data gives us a really clear contrast. In generalized anxiety disorder, or GAD, we see weakened connections between the amygdala and the prefrontal cortex, which basically locks the patient's mind in this constant, exhausting hum of low-level worry. But panic disorder is an entirely different beast. During a panic attack, the ventromedial prefrontal cortex, the exact area that normally tells us a sensation is safe, is knocked almost completely offline. The result is a sudden, totally overwhelming wave of terror. And this creates an incredibly vicious feedback loop. The exact moment the brain misinterprets a perfectly harmless sensation, like maybe a slightly elevated heart rate from climbing a flight of stairs, as a lethal threat, the amygdala fires a massive adrenaline surge. Now, the ultimate irony of panic disorder is that the fear of having the next attack becomes its own background anxiety. The brain turns into a 24/7 internal alarm system, which naturally makes the next attack highly probable. Okay, Section 3, Environmental and Social Triggers, focusing on hypersensitized fear networks. In social anxiety disorder, ordinary, everyday interactions transform into incredibly high-stakes performances. The studies point us directly to the anterior cingulate cortex. This is the brain's error detection system, and in these specific patients, it is wildly overactive. It literally magnifies every possible social mistake, flooding the patient's body with stress hormones before a conversation even begins. Now, with specific phobias, pay close attention to the timeline of the neural response. The amygdala activates so rapidly that the prefrontal cortex barely even has time to intervene. It's a near-instant fight-or-flight reaction to something that poses absolutely zero real danger. Honestly, just seeing a picture of a spider can trigger a full-blown physiological response, powerfully reinforcing avoidance behaviors that only concrete this neural pathway further. Agoraphobia actually builds on this, but through spatial mapping. Neuroimaging out of Stanford shows us how the brain loses its ability to place situations in their proper context. This happens because of weakened connections to the hippocampus paired with that enlarged amygdala we talked about. The brain essentially draws this mental map where anything outside a strict comfort zone is universally labeled as dangerous. This dramatically shrinks a patient's daily life as they restrict their movement to just a few safe locations, genuinely believing escape from anywhere else might be impossible. Let's dive into Section 4. Somatic and attachment loops, internal scanners and vigilance. Notice the striking contrast in how vigilance manifests here. In separation anxiety, the brain's attachment circuits are running hot. Any absence of a key attachment figure is interpreted as a literal, immediate threat to survival, which leads to elevated cortisol and severely disrupted sleep. Conversely, in health anxiety, we see a highly active anterior insula. The brain catastrophizes really ambiguous normal signals, like a simple stomach flutter, turning the patient into a hypervigilant internal scanner, constantly searching for a catastrophic terminal illness. Next up, Section 5, Performance and Obsessive Circuits. Basically, what happens when trying harder completely backfires. For performance anxiety, neuroimaging reveals a deeply frustrating paradox. When a patient feels evaluated, the amygdala activates strongly, which immediately impairs the prefrontal cortex's executive function. So, the harder the patient consciously tries to perform well, the more their own threat detection system destroys the very fine motor skills and memory recall they desperately need to succeed. It's a cruel loop. Then we have obsessive compulsive disorder, or OCD, which gets stuck in a hyperactive corticostriatal thalamocortical loop. Say that 3 times fast. Specifically, the orbital frontal cortex and basal ganglia get trapped in this urgent, agonizing what-if loop, intensely demanding rituals for temporary relief. But as you're going to see in the clinic, resisting the compulsion only makes the anxiety return much stronger, consuming huge amounts of mental energy over completely irrational, yet neurologically uncontrollable demands. Finally, we reach Section 6, Rewiring the Plastic Brain, Prognosis and Clinical Compassion. As the latest literature confirms, chronic anxiety undeniably reshapes brain structure and function over time. Grounding yourselves in clinical compassion is absolutely non-negotiable here. Your patients are exhausted because to them, normal everyday life feels intensely, mortally threatening. You have to remember, this is a profound structural reality happening inside their skull, not a failure of character or willpower. But here is the phenomenal news you get to bring to the clinic. The brain is remarkably plastic because we now know exactly how each type of anxiety seizes control of specific circuits. We actually hold the map for regaining that control. By using evidence-based approaches to strengthen the prefrontal cortex, we can literally rewire these pathways and quiet down those hyperactive fear loops. So, I want to leave you with this final thought for your future practice. When your patient sits across from you, you aren't just treating a symptom checklist on a clipboard. You are structurally rebuilding a hijacked brain. So how will you use this structural understanding of neuroplasticity to quiet those vicious fear loops for your future patients?